So, today we're talking about linear symmetries in origami tessellations, and I've got a couple examples here to show you before we dive into folding a simple version on our own. So, jumping in, this is my mirrored fish tessellation, where I've got these columns with mirror symmetry between them. Now, why mirrored fish? This tessellation shares the same motif as another tessellation that I call flying fish, which also has a columnar symmetry, but it's technically in the parallelogram symmetry that I talked about last week. Mirrored fish is the same on both sides, which is fun, and it has both one direction of linear, well, all mirror symmetries are linear, but one direction of mirror symmetries, and also twofold rotational symmetry. So this is the maximum symmetry available with this kind of linear symmetry. So contrasting with mirrored fish is adrift. I think of these as rowboats out in the middle of a lake or an ocean or something. Adrift has no rotational symmetry and no mirror symmetry. All it has is translation of one unit to the next and the next and the next repeat. And it can do this translation in two different directions. It's translating down to the right and up and to the right. So that's the minimum symmetry. And then back to some maximum symmetry. Interlocking Hearts has these columns with mirror symmetry between them, and it has positions of twofold rotational symmetry evenly spaced along the columns. The final option for symmetries is having these mirror lines, but no rotational symmetries. So this is my tessellation Pearl that has a lot of repeats in here, and we can see that we really want to have rotational symmetry in the centers of these rhombi, but they actually act different in the far range on either side. So here, these triangles are not overlapping the next pleat, and over here they are. Likewise, with the second rhombus, we have an overlap on one side, we do not have an overlap on the other. This causes the entire thing to have no rotational symmetry, and all we have left is the mirrors. So that's an introduction to the symmetry. If you brought your 16-fold triangle grid on a square, go ahead and get that out now so we can fold a simple tessellation in this symmetry together. So I'm going to start by locating the center of my grid. I'm familiar enough with these grids that I can just eyeball it, but if you're not familiar with grids, then what I would recommend doing is to fold the paper in half along a edge parallel direction, and then fold in half again, but not pinch, just locate that central point. One of the convenient things about having this half fold already in place is it's one of the folds that we're going to use for our next twist. So what I'm doing here is I'm taking this halfway fold, and one spacing to the right of my center point, I am going to split my mountain into two other mountains. So these three mountains are equally spaced around this point, one spacing along an edge parallel grid line from the center of the grid. So I bring these pleats together. So alongside the mountain, I have a valley, and I'm going to keep that valley on the same rotationally symmetric side all the way around my twist. This will make a closed triangle twist. So once we've got this closed triangle set up, I'm going to go ahead and squash it. So that motion was pressing down just outside of one grid spacing out from the center of the twist. I push and it squashes. And then I'm going to make a column of these twists. So what I'm going to do, I'm going to leave the edge parallel plate in place. And then in the other two directions, I'm going to go out one grid spacing and repeat this process where I take my mountain and at the designated point, I'm going to split it into a three-way intersection. And then I'm going to rotate these pleats around. Now you'll notice that this time I'm rotating in the opposite sense. I'm rotating in the left-handed sense, where the first twist I rotated in the right-handed sense. That's because these two pleats share, these two twists share a pleat, and that pleat has to lay down the same way regardless of which twist we're working on. So once I've got this twist, I'll go ahead and pop that into place. And I can continue down. I'm going to leave everything that's edge parallel alone. So those stay flat. And I'm going to work on these diagonal plates going out to the edge of the paper, each time moving one grid spacing out and putting in my next twist. So here's the part where you can be really glad that this video is recorded, and the recording will be up as soon as I'm done with the live stream, because I'm just going to go ahead and work my way down. And I've got this little partial twist that I can do here at the edge, but that's not going to make a huge difference in the final structure. And then working my way back up to the top, I can likewise do the same thing. So in the symmetries that we've been talking about this series, we've seen the equilateral triangle tiling show up before, and that's what we're using. We're using all equilateral triangles. We're not going to have any other kind of twist show up here. And this tiling showed up previously in the triangle symmetry session, which is not that surprising to see triangles in a triangle symmetry location. So once more, I have a potential half a triangle at the top. But what makes this different now is we're not going to put the next twists right up next to these triangles. We're going to space it one spacing out. So there's a couple ways to think about the easy way to go about this. One way is I could work on the side that has more space to work with, but it has this kind of half of a pleat up here that might cause some confusion. So instead, I'll work on the side that has only full pleats. And what I'm seeing here is a stair structure. So this is my finger walking up the stairs. So this is the top of the stairs. It's laying on top of everything else. So this time, instead of going one spacing out, I'm going to go two to find my target intersection. Going two spacings out, I locate my next triangle, and I'm going to let this bit of paper come underneath as I set this up. We'll get it back out shortly. And then I'm going to work down the stairs, going out two spacings each time. And here we can pull out this flap from underneath as our new mountain comes in and resolve that with a three-way intersection that we will later turn into its own triangle twist. And we can squash one and then the other. Now, I recognize this is getting close to the edge of the paper, so you might need to bring your hands up into the air to fold these very edgemost twists. But in general, I'm going to keep my paper on the table while I'm squashing twists as much as possible. So then I get to repeat that motion again. It's probably a good one to watch first and do with the recording later. And repeat once more. And the whole rest of the tessellation will consist of these same repeats. So now I've got stripes of triangle twists, and they have a mirror symmetric relationship to each other. There's a mirror line going straight through the center here. Now the question comes in, are there any twofold rotational symmetries? And it might look like there are. It might look like there's twofold positions between these triangles, but there's actually not, because this corner is different from this corner on the two sides of this position. So once we've got one stripe done on one side, I'm going to rotate over. I'm choosing to have the working area of the tessellation on my right-hand side because I am right-handed. And from here, we're going to go out two spacings. Now this is the pleat where I just have the valley and then the mountain is the edge of the paper. So on this one, we just get the one diagonal, and I'm letting this set up a lot of pleat overlaps over here. And then I can squash my half a triangle over here, which again is mirrored over this line between the columns, and then get my next two twists to come up. And what I'm going to do here is, so there's a couple ways to do the reference on this. You can either say, okay, the next twist in the column needs to be one spacing from the corner of the one I just made, or you can say the next one equivalent to this needs to be two spacings out from the next column. And, you know, why not both? So we can set both of these up at the same time. I can lay this lower one down as a three-way intersection and squash my twist above, then squash my twist below, and we're going to repeat that twice, maybe three times more. The third time will be a bit partial. And so I'm opening the pleat that's causing the overlaps, setting up the horizontal that I'm going to need, then opening the horizontal above, finding my two positions where I have my three-way intersections, laying down my bottom proto twist as a three-way intersection, and then squashing the top and then the bottom. I could also lay down the top as a three-way intersection and squash the bottom and then the top, but then I would be moving my pleat that's going and causing a bunch of overlaps, and that feels slightly, I don't know, difficult's not the word, but like it would wear out the paper. And then continuing on, I'm going to get another twist here and a partial twist up here. So now I've got 3 columns and I have space for one more. This will probably be a twist with one set of full twists a column with one set of full twists and a set of partial twists, because my mirror in the center is not precisely centered. So my center is a little further that way. So I would expect to have less paper at this edge than I had at this edge. So continuing, I'm going to find the top of the stairs. So as you go up the stairs, you can bump your toe and bump and bump, and once you're at the top of the stairs, there's nothing to bump into. Then 2 spacings out, I can set up my new twist. And as I predicted, we're going to have very partial twists for that second set. And I can do a teeny tiny partial twist down here as well. Again, this particular twist has really no structural bearing on the end result, just like these 2 up here. Completely optional swivel and squash type idea. Then I can set up my next twist up above. Again, using the 2 spacings out from the corner of the previous twist along that edge parallel pleat. And I can do this kind of double swivel and squash for the partial twist if I so choose, and repeat that twice more. And no, I'm not putting the video on fast forward. This is just how fast I fold normally. And get those partials. I like putting in the partials, especially with practice pieces, so I can test and see if I have a strong understanding of the pattern as a whole when I don't have that many references. So now we've got our practice piece, and you'll notice something. You'll notice that it's not square anymore. I started with a square piece of paper and it's not square anymore. It's squished. Specifically, it's squished, compressed in the direction parallel to the columns. Now, what other tessellations do I have here that show the same tendency? Well, there's pearl and mirrored fish. These 2 tessellations actually started out as great long rectangles. They started almost twice as long as they are wide. And now they are much more square-like in their finished state. So that's another feature to look out for with these linear symmetry tessellations. And so other examples, Interlocking Hearts is actually more squished perpendicular to the direction of the columns. But again, this one started out on a square piece of paper. It is not square anymore. And Adrift also started on a square piece of paper and is very much not square. This one, the squish direction is this way, which does line up with these columns. So there's some interesting properties with these linear symmetry tessellations that you might want to look into, do some test folding before you decide whether to use a different grid, whether to use a rectangle instead of a square, whether to try and get a different alignment on your project. So that's the linear symmetries. Now you've seen the maximum and the minimum and the in-between symmetries that you can have in this category. And you've seen how to fold a simple tessellation that fits the description. So with that, I leave you to fold whatever your heart desires, and happy folding.